right, so today we're going to start 8.3 functions in standard form. Today we're going to just look at graphing these functions. So a function of the form f of x equals ax squared plus bx plus c, where a does not equal 0, is the standard form of a quadratic function. The graph of y equals ax squared plus bx plus c has the line x equals negative b over 2a as its axis of symmetry, and the coordinate of the vertex is also x equals negative b over 2a. Okay. All right, so we want to graph the function y equals 2x squared plus 4x minus 3. So to figure out our end behavior, we want to figure out what is our value of a. So a here equals 2. And since a is positive, that means that our graph is facing up. So our end behavior is up, up. So next, when we're in standard form, we want to find our axis of symmetry. So we're going to use our formula x equals negative b over 2a. So we have negative. So our b value, I'm going to go ahead and write this up above. We have ax squared plus bx plus c. So b equals 4. So with the formula, we have negative 4 over 2 times our a, which is 2. So we have negative 4 over 2 times 2, which is 4, which gives us negative 1. So our axis of symmetry, I'm going to rewrite that, is negative 1. So I'm going to go ahead and go over here on our graph, and I'm going to go to negative 1, and I'm going to plot or draw that dashed line for our axis of symmetry. So our vertex, we know, falls on that x value of negative 1, but we need to find the y value. So we do that by plugging in the axis of symmetry. Okay, so if we plug that in, we have y equals 2 times negative 1 squared plus 4 times negative 1 minus 3. Okay, negative 1 squared is a positive 1. So we have 2 times 1. 4 times negative 1 is a negative 4 minus 3. 2 times 1 is 2. Minus 4 minus 3 gives us negative 5. So our vertex is the ordered pair negative 1, negative 5. I'm going to plot that point. All right, so since we know our end behavior is up, up, we know automatically we are going to have a minimum. And that minimum value is the same thing as the y value of our vertex. So I'm going to go ahead and write negative 5. All right, so the next thing we want to find to graph, remember, is either a point close to that axis of symmetry or our y-intercept. Since this is asking us to find that y-intercept, let's go ahead and plug in 0. So we have y equals 2 times 0 squared plus 4 times 0 minus 3. We'll notice 0 squared times 2 is 0. 4 times 0 is 0. So we're just left with negative 3. So our y-intercept is the ordered pair 0, negative 3. And that will always hold true. So I'm going to make a note here. The y-intercept will always be 0, comma, the value for c whenever we're in standard form. So that's a shortcut you can use. So our y-intercept is negative 3. I'm going to plot that point. And then we're going to reflect. So we count 1 to the line, which means we're going to go 1 away from the line. And then we're just going to sketch our graph. And there you go. All right, so we know our domain is negative infinity to positive infinity. And our range, our bottom y value, or our minimum, is negative 5. And we're continuing up to infinity. All right, so I want you to try this next function. y equals negative 2x squared minus 2x plus 6. Do the best you can, and we will review it tomorrow in class.